All right, let's see how things are going here. Make sure we're getting set up. Ooh, looks like we're good. All right. Let's see here. So I don't really have a plan today. Uh, Mostly, I'm just kind of getting on to take a look at stuff because I don't know precisely what I'm thinking about. I just kind of want to be looking at things. So it seems like I got on the Discord the other day and talked to some people about how to automate multi-building blueprints. And it doesn't look like that's a possibility right this moment. So they said something about it being a bug or something that was preventing that from happening. So we're gonna unfortunately have to table the um the builds. So I think the thing that I probably want to go back to is actually setting up a new set of commands for restarting the base and see if we can't start making some progress into automating some of the early game stuff. Um, Especially finding a location and getting the base all set up because my original version of that code is pretty bad. So we definitely want to go in and try and find something better. Um, yeah, definitely want to do that. So let's see about it. Let's switch to another faction. I think we should have a faction that is totally available. Nice. So here's what I'm thinking. Um, we need to decide what resources we want and what area we want those resources in. So, let's see here. The visibility range of this structure is 20. So you can see the visibility range of that structure is what you can see. Hey, what's up, Cassie? No, I am not going to be playing RuneScape anymore. Um, because of the changes that were made to the prices. Not that I'm upset that they increased the prices, but because when they did that, without giving anybody any notice, they took away a bunch of people's grandfathered rates, and some people lost some banked premium time, some banked subscription time, and I think that's total bullshit. You don't you don't make people promises like that and then without giving them any sort of notice or anything like that, just stop and take away those things when they've been supporting your game sometimes for decades. So fuck Jagex, and I won't be playing any of their games anymore. I'm really just sort of at that state with all MMOs. MMOs very specifically have a problem where, um, yeah, and I understand it's a personal decision. It's not something that I expect everybody else to follow suit on. but I have only put in, a few months, so the sunk cost there isn't nearly as much for me. So it's easy enough for me to say, oh, in the first 4 months of me playing, you pulled one of the single most anti-consumer moves I've seen in gaming. I'm not going to stick around for the long haul when it only took 4 months for you to do something that was just absolutely atrocious. So, and I don't think it's the dev team's fault, right? Obviously, they don't make those decisions. It's all down to the private equity company that purchased Jagex is driving those decisions. And that's just kind of the state that we're in, specifically in the MMO genre, because MMOs are so expensive to make and maintain. There's a lot more outside funding required to get those games made and to maintain them. So they're sort of in this constant state of getting into bed with people whose only goal is to make more money. And so things start to get shitty. Absolutely. And I'm not mad that they increase the prices, right? I get that you need to get some of that money back when you take away the microtransactions. But that's not an acceptable reason to break a promise that you made without giving people the opportunity to comply with the new rules you're setting. Right? If you want to take away grandfathered rates for people who are on the year-long plan instead of their month-to-month plan, that's totally fine. You're allowed to change that rule, but you have to tell those people first, because previously you have said all you have to do is maintain a subscription and you'll keep your grandfathered rates. And then all those people who were keeping those grandfathered rates through yearly subscriptions weren't given the opportunity to go back to their month to month and just lost their grandfathered rates. And that's bullshit. And you can't do that. You're right. Technically, they can. So I guess what I should say is you can't do that and still have me play your games and say nice things about your company. So you're absolutely right. You can go ahead and be a piece of shit. That's totally fine. But I'm going to call you a piece of shit and not play your video game. Because I can do that. But like I said, I mean, I think it's just the MMO genre in general falls victim to that a lot. Because when you start getting people, bankers, private equity, stuff like that involved, their only goal is making money, oftentimes to the detriment of the product, right? That's where, all this stuff about hostile takeovers and parting out companies and stuff like that, right? It's all the same people who do those things. Their only goal is to churn out as much profit as possible, not churn out a good product. And because MMOs are so expensive, they end up, I think, falling prey to those people more often than a lot of other types of games. And so I think, honestly, the future of multiplayer gaming is probably going to be in games like this game. Not necessarily like the RTS factory builder stuff, but specifically um, games that have the option for like player-owned dedicated servers so that we can, have our own servers, do our own infrastructure and stuff like that. So the game doesn't have to have this live service model. Opening things up to modding, having modding APIs so that we can generate content for ourselves, and just building a good platform for communities to build up on their own, and modders to change some of the things about the game to suit specific communities, I think is just a better way to have large scale multiplayer stuff. We've seen it with Ark Survival Evolved and Ascended. We've seen it with Minecraft. We've seen it with a ton of those games, and they do really well. And, you can have a small community of just you and your friends. You can have a large community where you rent, a virtual server. And those things have done really, really well in the past. And I think I'm probably going to start focusing on some stuff like that. Roamstead will come out. We'll get a dedicated server for that. We've got this Desynced game has been a lot of fun. I've been enjoying learning about its programming language. So I am currently running a dedicated server for this game, for a team that I'm putting together of people to automate the game with the integrated visual coding language. And I'll probably just focus on things like that so that I don't have to get involved with the large money interests that ruin a lot of other games. Because I don't want to deal with those people, because they're soulless and they're greedy and they have no value. But today, I think we're going to be, like I said, revisiting our startup script that finds ourselves a good location and then sets up our base. So we've got our visual range here of 20. Once we actually make the command center, I believe it grows to 30. So we have a little bit of a problem in that we're not able to look at the entire area that I might want to look at in this first go, right? Because I'd like to observe the entire visual range of the built command center in order to decide where the best location is. So what I might do is I might instead have all of my scouts go look for a bunch of different resource nodes and catalog all of those resource nodes, and then have my command center check to see. I don't know exactly what the math would be on it. But if I got all four of these, right, the command center, the scout, and my 2 engineers to go explore the world and look for all the resource nodes they could find, and then send them back, and we could check them just like we do on our mapping script to see if they're duplicated, right? So we don't duplicate any resources. And then if we got the math done so that we didn't, so that we could find out where the thickest concentration of resources are. And that's some pretty complicated math to go through and find everything that's within like a centralized 30 visual range. And then build the base literally just right in the middle of that. I think that'll be fairly complicated. We've got our crystal here. Actually, this is a really good spot. I almost just want to build this base literally right here, which is kind of funny. So let's see. How do we figure this out? What do we need to do? So, what we'll need to do is we'll need to find a bunch of resources. So I don't know if we want to map every resource, because that'll take a lot. Or do we just want to map large resources? Right, because these big resources normally have lots of other little nodes all around them. So that might be the better way to go about it. Hmm. Man, this is a hard problem to solve. This is a really hard problem to solve. Hmm. Goodness gracious. I don't know even really how to get this problem started. I think probably trying to do this particular thing live right now is not necessarily a good idea because there's going to end up being too much research involved. Because I don't really know the math behind trying to find the point, the coordinate point that most of those things are associated with. I'm sure there is some math for it, but there's a diagram somewhere where all the radiuses, all the 30 distance radiuses all meet, right? And there's definitely some math to figure that out. But I don't know what it is off the top of my head, so I'll have to research it. And maybe we'll try that tomorrow. The scouting logic is fairly simple. So that's something that maybe we can consider is we're going to have 4 units to scout with. And so what is a good 4 unit search pattern, right? You could go out in cardinal directions and then like do a loop back at an angle and then do another go out and then a loop back. And so everybody could do like 4 quick loops, right? Out, back, out, back. And that could potentially get us everything. It might only need to be 2, like out one way and then kind of around and then back in at the angle. Because this right here is a 30 visual range. So what I'm looking for is the most resources I can get inside of what you're seeing here on the mini-map, which is pretty significant. And so the visual range, let's see. So there's math on this as well. How far can we go out where the visual range of our vehicles, which I believe is only 10. Oh, it's only 7. So the Scout only has a 7 visual range. What do these engineers have? The engineers also only have a 7. So the diameter, not the diameter, the edge of this, at what point does the number of tiles, so it's also 7 by 7, right? So it's 14. So if you go out directly to the left of a point, then you've got 7 going down this way. And if you come down this angle, then you basically go 14 around this edge, right? And then you've got 14 available around this edge because something else came down this way. So 14 and 14 is 28. So at what point going out this way does the circumference of one of these edges equal 28 squares? Because that's what you would be able to see in a single 2-sweep pattern, right? You could come out and then you come around the edge and then you go back in, and that should give you vision on everything within that 90-degree angle. And if I could do, I mean, that'd be a really quick search pattern, right? Everything just boop, goes out, spins around, comes back, catalogs all the big nodes into a map, and then we run some math on those nodes to identify the location where we would get the most Or would it be better to go out farther and then do a sweep back in, right? Like a reducing, because as you come back into this angle, you would need to go less and less distance through that angle, right? And so you could come out really far and then you could sweep down and then sweep back up and then sweep, sweep, sweep until you get back into the main area. And maybe that would be a way to search even more area. This is interesting. We also have to consider that there might be enemies, right? We might lose some of our starter buildings if we do it that way, especially if we go too far. So that's interesting. What do we have? When we get these things started, all we have is a fabricator, right? It doesn't look like a fabricator could make... what I'm trying to figure out is if I could make some additional defense components. What it might take to make some more small turrets. So a small turret requires chips and metal bars. When we start, it also requires the fabricator, or the assembler. When we start, let's go back to one of the starters here. Let's switch factions. Go back here. When we open up our drop pod, we have, okay, so we actually have enough of these to outfit all of these guys. What would it take if we equipped this? What does it take to make the assembler? The assembler's 10 crystals and 5 plates. We don't have any plates. Okay. That's probably not in the realm of possibility, right? What does it take to make a plate? Takes 2 of these. So 10 of our resources would get taken up. In order to try and make the assembler. And then we use the assembler to make those other things. So we get 20 of these, 10 of these. We have an extra fabricator, which is interesting. And then it takes, whoops. And then it takes 5 and 1. So we'd be able to make 2 more small turrets. Without really needing to do anything else. We could also go mine some minerals. And make 5 more bars to make a 3rd small turret. And the reason that I would want to do that is as a hedge against getting dropped in certain spots. Because the goal of this is to be viable no matter where you get dropped. And so you might get dropped in some hostile territory. And if you do, then you need to be able to overcome that. So some things that we're going to want to look at. We want to look at the circumference, right? The radian value maybe? of how many squares this takes up based on how far you go out. And then we want to do that in some sort of multiple of 7 so that we can travel that edge and then go back and forth and back and forth. And then we also want to try one where we just go out to where the radius edge or the circumference edge here is 28 and then just go back one time. Right, just boom out, boom back in. Super short search, but maybe not a large enough search to get the good area. We'll want to try both of those. So circumference is what? Pi r squared. And then you want to divide that circumference by 4. So what we're looking for is a circumference that is 28 times 4. Actually, it's 28 times 4 plus 4 because you also are going to go straight out on a line. And so your radius is 7, but it's actually, your diameter is actually 15, right? Because you got 7, 7, and then the one you're on. So it's not a true radius because it doesn't count this guy. Doesn't count the square you're on. At least I don't think it does. Let's find out. Let's go get this dude off on his own here. Where just his visual radius is available. And then we'll count it. Oh, he doesn't have the grid. So that's much more difficult to count. Well, dookie. But it doesn't actually seem, you see there's a really flat spot right here. It doesn't go all the way out to a point, which is what you would expect. Okay, how are we going to give this guy? Well, actually, no, we can't count from here either. This is 3 on a side, so let's see. The range of this little duder is 10. So let's see. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, that's interesting. So it emits a range that is completely outside of itself. So what I would have thought is that the center would have been the origin. And because of that, it would have only gone 9 beyond the edge of the building. But it actually does go a full 10 beyond the edge of the building. That's really interesting. So it's likely the same thing is true of the visual range, is that it uses the edge of the building, not its center point. So things like these 2x1s, right, if we look at their visual range, it's 15. So I'm sure it does the same, right? It's probably 15 this way and 15 this way, but it's got 2, right? So the it's 15 and 15 plus 1 going left and right, which is 31. But then up and down, it's actually 32. I bet you it's not a complete circle, which is strange. But our units all only take up 1 square. I wonder if the command center takes up 2 squares, because it's quite a bit bigger. Not this command center, but the mobile, the unit version of the command center. I wonder if that takes up 2 squares. That's interesting. Okay, so we've got 7. The visual range on the command center is actually higher. Let's go back to this faction over here. I believe this is 10. No, it's 20. Okay. See, so that's interesting, because that throws the whole thing off. Because these are all the same. They've got 7. And then, let's see, this one's got a much faster movement speed. So coordinating these to effectively work together doesn't really seem like it's gonna work, because their ability to scout is all very different. That's interesting. What to do, what to do. The other thing is we also have to look at these capacitors, right? They start out full, but they're only so much, right? They can only do so much. This one's got a power cell on it. So I need to figure out how much power they eat. They drain 250 power. Is that a tick? I wonder. So 250 power a tick would be 1,250 a second. Let's go 1 Mississippi. No, I think it's 250 a second. Not even 250 a second, because it's only drained 400 now. It's been a lot of seconds. So that's 500. That might even be every 10 seconds. Or every 5. Okay, so I don't know exactly what the power drain rate is. I don't know how many seconds it's looking at there. Maybe I can find... got like a wiki or some shit. Let's see, codecs. Power. Power producers, batteries. Looks like the introduction has power in it. Okay, game screen. Nope. Logistics network. I don't see anything about power drain in here. Well, this definitely has something about power drain in it. The unit runs out of power, blah, 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 blah. Power producers, batteries. Oh, and their power will drain. How a battery recharges depends on the type of battery. Batteries within a logistics network make their power available when consumption exceeds production. They have limited charge and discharge rates, depend on size. Battery utilize the excess power in the logistics network they are in to recharge, and are very effective when used in conjunction with solar cells, for example, to compensate for power loss during the night. Okay. But it doesn't really say what the drain rate is. So I think what we need to do is just step right outside and then take a look at the number of seconds that pass. We're going to wait until 1740 here. Boom. And we're going to wait until it goes down 250. That was pretty close. It was like 12 seconds. 12 or 13 seconds to drain that 250 power. So we'll call it 10 seconds. That seems the most reasonable to me. So we've got 10 seconds times 4. So that's almost a minute. So it's almost 10 minutes that it can run around searching. As long as it's not mining or fighting or anything like that. That's quite a long time. We could get a lot of scouting done in that time. Okay. So, looking at this, pi r squared is the circumference. We need pi r squared to be equal to 29 plus 4. Or 29 times 4. So, let's open up our calculator. And let's do 29 times 4 is 116. So pi r squared needs to equal 116. Pi, I think I need to go to a scientific calculator. There we go. So pi is 3.14, a bunch of other bullshit. So 116 divided by 3 gives us 38.6. So 38 divided by 2 let's see, 38 divided by 2 is 19. So let's see if 19 well, let's see if 38 times pi. $38 times pi equals 119. 37 times pi equals 116.2. Okay. And then 37 divided by 2 is 18 and a half. So 18 is 36. 36 times pi is 113. So do we want to go out 36? Or do we want to go out? Well, let's think about that too. So if we're only going to go search 36 each direction, and the visual range of the built command center is 30, then that doesn't do us any good, right? Because we're effectively just always going to build right where we start. And not really do any sort of exploring. And if that's going to be the case, right, we might as well just boom, trigger it right here every time. Because the visual range of the constructed command center is 30. So if we're only going 36 out to go look for stuff, we're not finding very much more than we would just naturally have. So that's silly. I'm starting to think that just building the command center right where it is might be the best option. You might want to do a little bit of moving, right? Like you want a big crystal and a big metal inside of your network radius if you can get them. But other than that, there aren't really, because everywhere you go, you just find good resources, right? I guess you could maybe focus more on the silica, right? Finding a plateau to get silica because you need silica early game. So maybe that's what you do. Maybe you specifically look for a place that has, a big crystal, a big metal, and a big silica within the 10 range. And in that case, I don't think you necessarily want to go out and then come back in. If that's going to be what you're doing, then I think you want to go look for a plateau and then explore around the plateau, right? Because the plateaus are where you get the silica nodes, not just these silica trees. So maybe, is there a way to search specifically for a biome? Let's look in the library here. Let's create a new item. Create a new behavior. Boom. Testing. And then let's see. No biome. What I want to look for. So I know you can check your altitude. Right, you can see if I'm in a valley or a plateau. And then the target can be the unit or coordinate to check. So figuring out where to decide, right? Because you don't necessarily want to check just the unit, because then the unit has to physically get up on the plateau. But you also don't want to necessarily check every single coordinate within its vision. You might be able to just check all the coordinates around its circumference. And so just constantly be sweeping the edge of its vision to see if you bump a plateau. And if you do bump a plateau, then you check. The other thing you might be interested in looking for is aberrance, because that's where you get the laterite. So you're kind of looking for like a plateau and aberrance, like right next to each other. Because you're likely going to be able to find metal and crystal pretty much everywhere. But if you can find aberrance and a plateau right next to each other, then you could get your laterite, you could find your metal, you could find your crystal, and you could find your silica all together in that case. So, how do we deal with that? How do we find the view on the edge? More math that I don't understand. It's probably going to be a loop number. I guess the other option is we could loop nearby resources, specifically looking for silica. This is actually probably the answer. Instead of looking for an altitude, we probably want to loop nearby resources, specifically look for silica, and then if we find silica in a high enough concentration, we need to switch to a new search pattern. Right, because the best way to do it is to just go looking for the type of environment that you want and then narrow it down to specifically the place in that environment that you want. Now, so here's another issue, I suppose, is that your first encounters with bugs normally happen on plateaus. So if you set it up to go search for plateaus, you're probably searching for bugs, which could create a pretty big problem. So we might actually want to go ahead and identify, go get some crystal real quick, go get a little metal real quick, make up some more lasers, and then equip everybody with a laser. Because that shouldn't take very long, right? I mean, you're talking 30 seconds to at least mine all those materials. And then you would just equip this medium slot with your assembler, and then you make a couple more, and then you pass out those, and then you equip the assembler, or these have enough inventory slots so they can hold. Yeah. I think it would be doable. And that way, if you find some bugs, you can be okay. Because that is kind of what you're going to be searching for. So let's explore around a little bit here, just manually. And let's see. Okay, so like here's a plateau. And now we've got some silica. And we've got some more silica over here. So immediately, this would be a place that we might want to look around at. And while we're looking around, we're going to want to find metal and crystal. There's plenty of crystal here, but I don't really see any metal. So probably we would end up leaving this spot. And then we'd end up finding this spot. And there's plenty of silica here. These are interesting little plateaus because they don't have a lot going on. Ooh, there's a really big one over here. And we would end up looking around, and we would only really find crystal again. There's not really any metal around this area. And so we would keep searching, and we would find this silica. And we would find this crystal, and we would find basically no fucking metal. That's interesting. Does metal only appear in the desert, really? Oh, now we got bugs. I fucked it. Oh, we got a laser. Okay, so here's, yeah, I think the metal primarily grows in the desert with the laterite. So I wonder how common it is to get desert plateaus. Because that's probably what we're looking for, right? Because like here we've got laterite, metal, crystal in some decent amounts. And then honestly, we go in a little more. But there's no silica here, and you have to have silica early game. Because you got to make computer chips and tubes and all that other stuff. But it doesn't seem like plateaus near or inside deserts are really a thing. So you kind of go desert into grassland into plateau is what it seems like. And you don't really jump over the grassland and go straight to plateau. So I don't know if this idea of finding silica near the other resources is going to necessarily be the most viable. Because like here's a plateau that's kind of close, but it doesn't have any silica on it. I don't even think you can get on it. Which is interesting. It also doesn't seem like there are very many choke points in this game. As far as I don't know. The map is really open and flat, it seems like. Maybe it's just the area that I'm in specifically this time. It definitely feels like specifically laterite and silica are sort of at odds with each other, as well as metal ore and silica. Right, lots of places I've found so far where there's good silica up on a plateau and a lot of crystal. But I have not found all three of the starting resources. Here's almost a good spot. We've got some metal ore, we've got some crystal, and we can get to the silica. Right, there's some good silica right there, good silica right there. We get some bug hives over here. But like this is the first area that I've found that I would call a really good spot. And honestly, even this crystal here is a little lackluster. There's a little more over here as well, but all these are kind of small, right? There's no big ones. But we've got a good big silica right here. I mean, we can mine this specific silica for a long time. This is actually maybe something I want to consider is building my storage buses and my gathering, right? Just build a gathering building and attach it to a storage bus right next to these larger mineral deposits and then just mine off of them and just store it in the bus. And then if the bus ever gets like 3/4 full, just stop mining until it goes back down to half. And then we could just have mining structures doing all of our mining. Now, eventually, those buses would sort of fail because there wouldn't be enough resources around, and we'd need to revert back to mobile resource gathering. But I think right at the beginning, like right at the start, I feel like structure-based mining is probably the way to go. I don't really know though. It's hard to plan things out in this game before I've really gained a ton of knowledge. Because I really just don't know a lot. Right, I've only ever picked up the first set of basic behaviors or basic research. And so I just don't really know what I don't know. Hmm. Interesting. Here's honestly probably the best spot that I've come across so far. We've got metal, we've got pretty decent crystal. Maybe second best spot. That other spot was still better. We've got silica, crystal, metal, pretty much all within grab range here. But it is. I mean, like, you got to be on a plateau also next to some desert is pretty important, it seems like. Let's go back into this testing thing here. I want to see. I want to see if we can figure out if we're in a desert or not. Does anybody know off the top of their head what how you might be able to check this? Surely it's got to be like in a global. Board construction, place, can produce, debug, faction, distance, location, resource type, the season, stability. Doesn't seem like we have a way to identify. We really only get information about whether or not something's a plateau. So we sort of need to go back to specifically looking for a resource. And then when we find that resource, we need to look for everything else. So specifically, we're looking for silica. And then once we find silica, we're looking for metal and crystal. And so we need to decide on a threshold for each of those things and a distance from a central point for those things. So once you have 3 points, you can triangulate the most center position of those 3 points. Ruby, hey, what's up? Welcome to the chat. Welcome to the channel. Thank you for the raid. How was your stream today? How you been? Hey, what's up, Guardian? Were y'all having your weekend group stream? Was that what was going on there? Playing your goofy ass horror games? Nice. I like it. Y'all are braver than me. I don't do scary. I am a big wuss. That's funny. How do we do the math on this? So we need to identify an area where there's silica. Unfortunately, I've got to raid and run because I got work, but enjoy your game. I will, Guardian, and thank you very much. I appreciate you stopping by. This is sort of an RTS, Ruby. This is a factory builder RTS kind of a game. So it's got a little like Command and Conquer, StarCraft / Factorio in it. The reason specifically that I'm playing it is it has a visual scripting language in it that you can use to automate all of the activities of all of your units. And I think that's really cool. So I'm going to be doing that. It's also a multiplayer game like your other RTSs. And so what I want to do is I want to automate it and then compete against other people who have also written a bunch of automations, and have like some automation battles. Another game that's worth checking out that's similar is called Silica. Half RTS like Command and Conquer, half FPS. Oh, that's interesting. Yeah, like a Command and Conquer. What was it? Tiberian Sun was the one that they made that had the first person shooter aspects where you could take over one of the units. I think it was Tiberian Sun. Hey, what's up, Occam Sphere? Welcome, welcome. That's very interesting. How'd you enjoy the stream today? Oh no, Bug's gonna come get me. Zap. It's a little trippy. It's a really, really deep, fun game. And it's been really, I mean, I've been playing this game for a week now, and I've made almost zero progress. Mostly because I'm trying to program everything and do everything automated instead of manually. But yeah, I mean, the game is super duper deep and complicated. And it's going to take a lot to complete my objectives because I want to get everything automated all the way through the game. Ooh, this is a really good plateau. And there's some good silica. But it doesn't look like there's any other good resources here, which is too bad. Oh, there's some good Oh, what is that? What in the holy shit? Why is there a Ravager? I don't know. They might be. Looks like they getting a little freaky there. I am terrified. Let's go this way. No sense in interrupting people during their private time. It's just rude. Oh, there's a lot of bugs over here. Goodness gracious. Yeah, so what I'm trying to do right now is I'm trying to figure out what the conditions are that create really good base locations. So there are 3 resources that early in the game you really need. You really need crystal, you really need silica, which is these white little piles, and you really need metal ore. The problem I'm running into is metal ore tends to spawn in the desert, and silica tends to spawn on the plateaus, and they almost always have an area of grasslands between them. So I'm having a little bit of difficulty trying to find all three of those. So the thing that I want to do is I'm trying to come up with an idea for a scouting script at the start of the game. And what this script is going to do is it's going to send all of the units out to search to find as many instances of these three resources as it can. And then we're going to do some math on all of those coordinate locations and find the place where there is a good crystal node, a good metal node, and a good silica node, all the closest to a singular central point. Yeah, I do. I need to find like a thin grassy area. And we found a couple of places. Right. Exactly. We want to find all three of those and then triangulate ourselves a base location in the center, which is all math that I don't know how to do. The last time I passed a math class was like pre-algebra in the 8th grade. So me and math don't really get along. I know that there are existing equations that can absolutely do that, so I'm just going to have to research those things. But for now, I just kind of want to explore this world a little bit and see if I can really drill down on what it is that makes for a good base spot, and see if I can think of some stuff that I can pull in as data to help narrow down my search as quickly as possible. But I'm having some struggles. We could also, so in the grasslands area, sometimes you get these trees. They don't have a ton of silica, but they have a little, and they're fairly abundant. So another potential option is to just find a place like that, but I don't know. I would just draw it out, then mark out halfway on each, then connect them across the middle where the lines meet would be the middle. Yeah, absolutely. So I could definitely do that visually and manually, but I'm trying to automate the process. And so all the computer has access to is the coordinate values. So it needs to draw those circles itself. So, you know, there's a math in there somewhere that draws those circles and can find those intersection points. But I don't know exactly what that math is. This is not a problem that's unique to this game, right? These are established scouting and triangulating equations. And so I'm not like trying to reinvent the wheel. Right, exactly. Exactly. I don't know what like the name of those equations would be off the top of my head. It's going to take quite a bit of research in order to figure that stuff out. Might have to talk to my brother. Oh my gosh, here they are again. Another Ravager and another Malika. I'm gonna pop out and rest. It's midnight here. Clocks are going forwards tonight, and my brain is fried. Yeah, have a great night there, Ruby. Thanks for stopping by, and thanks again for the raid. I really appreciate it. Okay, well, I think the first thing we need to do when we look in here is we need to be looping nearby resources. And we're going to name this variable current resource. Actually, I don't think this is what I want to loop. I want to loop nearby units. And the reason I want to loop nearby units and not resources is I don't want to find... Hey, what's up, Cav? What are we working on now? We've gone all the way back to the beginning, Kev. We are working on the base startup logic again. Now that we've learned a little bit more about the game, and we know that our original base building logic was garbage, we're going to go back and see if we can't do something better that finds a better location. So what we're going to do here is we're going to loop units. The range that we're going to use is going to be massive because it'll cap out at visual range, and that's what we want. And then we're going to filter these for silica, but not silica sand. We want the type, we want the gatherable silica deposit. And then we're going to get this, and it's going to say current node. Okay. So we're going to get a silica node. And when we get that silica node, we're going to compare. And what we want is, let's see, can we compare number? Nope. First, in order to compare the number, we need to get resource number. There we go. So we're going to get the amount of the resource from our current node. We're going to get this result out, which is node amount. We're going to compare that value to a hard-coded value. Let's say 1,000. So there needs to be at least 1,000 silica in a single node. If it is equal to or larger than that, then we will jump to a new set of instructions. And we'll give that a label. And we'll use a really simple label. We'll call it the silica. And then if it's smaller, so we don't at least find 1,000 silica, then we'll just keep doing the regular loop, which is looking for silica. And then if we do get that, we'll go ahead and put a label. And this will be what we jump to here. This label is silica. And this is going to be a new set of logic that is going to have us maneuvering around differently. In fact, well, no, we don't have two behavior controllers. Bummer. So once we find the silica, we will start searching for our other resources. So I guess actually what we should do is we need a new loop here. So once we find the silica, we hit the loop again. And this time we're going to loop units. We're going to do the same large range. We're going to hit a filter, but this time, instead of filtering just for silica, we're going to go over here to the info screen, and we're going to filter for mineable resources. And then once we get that, we'll get current okay, let's cancel this real quick. Let's rename this one. This one is currently called current node. I'm actually going to call this one current silica node. So this is specifically the variable we're using when we're only looking for silica. And then down here, we're going to make a new value that is current multi node. So the current node when we're searching for everything. So there are two things that we need to do with these nodes. Number one, we need to store their coordinate values in an array. And in fact, we also need to store this value in an array. So we're going to go boom, memory insert, right here. And the index that we're going to use, we're going to create a nice new mineable resource array right here. And the value we're going to input is current node silica. So we're going to add that into the memory array. And then when we come down here, actually, we don't need to, oh no, that's right. These are, I was going to say I could just put the filter for each of the different resources I'm looking for in here, but I can't actually do that. So we're going to get type, get unit type from this current unit. We're going to get that type right here. We're going to get multi-node type. Okay, so now we know what type of resource this is. Does that actually help us? Because we can get the type and the value. Okay, so what are we wanting to do? We want to compare the value. So instead of get type, we want the number like we had before. So get resource number. It doesn't matter what type of resource it is. multi-node amount. Because all we're looking for is the total. Right? No. Before we do this, one of the things we probably want to look at is if there are even enough resources within range of this silica node before we do all of this right here. Because this is going to be what we need to do our triangulation. We want to find the node of type crystal, type silica, and type metal that is the largest node. And then we want to triangulate those and find the center point of those three nodes. And so within, gosh, we only get like 10 spaces. Let's even call it 20. So within 20 radius of this silica node, we need to find crystal and metal. Actually, within a 20 radius of the largest silica node. But I guess we can just search this one. That's fine. Just the first one we find that has at least 1,000. We'll start circling around it. So can I loop? Okay, this is units in range of the unit that I'm using. Is it not possible to loop based on this unit right here? We want to find every unit. We want to find every resource within 20 of this resource. Actually, we can make it a little bigger. So the radius of the logistics network is 10. But the diameter is 20. So we could actually go a little further even and maybe go within 30 of this right here. And so because my visual range is radius 20, its diameter is 40. So what we want to do is we basically want to move in a circle around this silica node at 20 range, right? At the edge of our visual range. And if we do that, if we make a big circle and save, while we're making that big circle, we save all of the crystal and metal deposits that are within that circle, then we can pick out the biggest crystal and metal deposits that are all within, say 20 of each other. So we can't just pick the biggest crystal and the biggest metal. We have to pick the ones that are closest. So we can narrow that down. We can narrow that down fairly easily too. So we need to decide, is metal or crystal more important? Do we want to get, so if we get the biggest crystal deposit, then from there we can just find all of the metal deposits that we've stored that are within 20 of that crystal deposit and also within 20 of the silica deposit. And if we do that, then we'll know, okay, those are the 3 nodes that we're using for our triangulation. And then we just, boom, find the center point between those 3 coordinates. And that's where we build. So silica first. Then we search around. So how do we drive in a circle around a center point? What do we want to do there? What's the math for driving in a circle? I think metal's going to be more important than crystal. Okay. Let's do metal second then. What's the math on driving in a circle? How do you fucking drive in a circle? You use exponentially more metal than crystal, especially early on. Okay. Yeah, I did not know that. I'm so new. I don't know anything. But that's good, because we'll find the biggest metal, and then it doesn't really matter, as long as there's some decent crystal, that's fine. And then, so we need to obviously set up some thresholds as well. So we've got our threshold for our silica. Well, no, I guess, yeah, we'll set up the thresholds as we do the search. That's fine. But we need to go in a circle. How do we drive in a circle? Calculated X and Y for offset, regularly updating. I don't believe an actual circle is going to be easy to calculate in game. Hey, what's up, Bram? Yeah, so there's a couple of things that I can do. For example, nope. Distance, nope. Move. So we've got things like move offset that would allow us to maintain a distance, right? So I can put a move offset of 20 from this unit that we found here. So this is my current silica node. So I can pick that unit, and then I can update this to be a 20 offset. So I guess I could do the 4 different offsets, right? You've got plus 20, plus 20. You've got minus 20, plus 20. You've got minus 20, minus 20. And you've got plus 20, minus 20. And if you did those 4, that could make a circle. You'd have to do them in the right order. But I can use this unit's value, and I can travel. So minus, minus, minus save this and go out. So, okay, so I'm going at angles. So minus nothing is this way. So no offset X, offset Y. And then no offset Y, offset X. So no offset minus no offset. And then no offset plus, and then plus no offset. That seems simple enough. And that'll just drive us. And it'll drive us at an angle, right? It won't follow the curve. It'll just go boom, 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 and make a diamond. So I guess that's not really a circle. You could get granular with it, right? So I could move from here to the center point, to the top, to the center point, to the side, to the center point, to the bottom, to the center point, and back. And that would do more of a circle. And so the more granular you get, the more of a circle you make. So let's go in here. And we're always going to start at an offset of 0x plus 20y. So we're always going to stop top middle. So even if we find the silica from below, we'll always just start top middle. We could do some logic to figure out which side we're closest to. We could get the coordinate locations of each of the offsets we wanted to do, and then loop them based on our distance, and start at the one that was closest. But if we did that, then we would also have to put in logic that determined what the next one was, instead of being able to just hard code it. Because this way, I can just hard code these, right? So I can go CV, and then we can move here, and instead of this offset, we'll go 20. Oops. This one actually needs to be negative. So we'll go to negative 20 here, and then we'll go negative 20, 0, which gives us the west. So we're going to go northwest, southeast, counterclockwise. Don't ask me why. We're just going to. And then we go 0 again, positive 20. Okay, that's correct. And then we go positive 20, 0. Whoops. Positive 20, 0. Save it. And then we actually want to go right back to the first one. Okay. Sweet. So now we want to wait while we're moving, right? Is there like a wait move? Or will it naturally wait before it moves on to the next move? That's something we'll have to explore. But this will get us in a circle, right? We'll go to the north. And then we'll go west, south, east, back to the north. And that's one rotation. And that will allow us to simultaneously be scanning for resources. So this is going to be difficult, actually, because we do need to simultaneously be scanning. But we've jumped to this location. We almost can't do this without two. Damn. Almost can't do this without two. I guess if we do, let's see, if we do the middle ones as well, we can stop and scan at each point. If we had two behaviors going on, then we could just be scanning while we were moving, which would be super cool. But I don't think that's possible because we'd have to make another integrated behavior controller. And I don't think we can do that right out of the gate. I think you need some sort of research in order to do that. So what is the difference? A 20 range difference. We're starting here. And we're going so it's the hypotenuse of a right triangle. Is that right? No. No, it is not. Because we're not actually going all the way up to the corner. This corner would be the hypotenuse of the right triangle. But we actually want to be right here. So we need the slope to the radius, or the slope to the circumference. Right triangles are centered on 0, 0. Oh, okay. Yeah, so that would take us through here, though, right? Because if we centered the right triangle here, then the hypotenuse actually travels through here, not all the way around. It goes like this. So at a visual radius, or at a radius of 10, which is the radius of this, it goes up and over 7. Right? 1, 2, 3, 4, 5, 6, 7. That's funny. Cav, I say the same thing. When people say stuff, I'm always like, your face is a such and such. That's hilarious. Normally I do it when they say something nice, like, though. Like they'll say something like, oh, that's so pretty. And I'll be like, your face is so pretty. Like it's an insult, but it's not really. Because I'm a weirdo. It's nice to meet somebody else who's the same kind of weirdo as me. 'Cause I'm a freak. Tell people to shut up when they sneeze. That's actually pretty funny. Okay. So what is this? How do we find this? It looks like it's always going to be the same amount, right? You're always going to go up and over the same because you're going at a 45. And you are going in a... So this one is 7, right? It's 1, 2, 3, 4, 5, 6, 7. And that's on a 10. So what if I just do the offsets at 14s? And just hard code it, right? Minus 14 plus 14. Or minus 14 minus 14. It's not perfect, but I feel like it'll be okay. So we also, well, we might need this one. So we go up to the center. And then we go to minus 14, minus 14. And that'll take us around. And then we go there. And then we're going to go minus 14 plus 14. And then we go to the south. And then from the south we go plus 14 plus 14. Right? So minus 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 plus plus plus. And then we're going to go plus on the x, minus on the y. Then we'll go plus 14, minus 14. Oops. And then we need to completely go back to the start. That seems right to me. It doesn't seem... It doesn't seem right. Because you would think the distance, you would think it would be like minus 10, minus 10, because that would be in the middle of those two numbers. Oh no, that's right though. Because it's a circle, not a fucking triangle. If it was a triangle, it would be minus 10, minus 10. And that would be the center point of the hypotenuse. But that's only if it's a triangle. Because it's not, we gotta bulge it. I don't know. That seems weird. And then at each one of these points, we need to pull all of the information. So I think the way I wanted... No, we can't do it that way. I was going to say the way we want to do this is to pull, make a call and then set the array. But that would set the array inside of whatever whatever we were calling. Oh, that's interesting. Hang on. If we call, so something that happens right now is your array is explicitly tied to the behavior module that it's attached to, right? So if you're using an integrated behavior here, let's set a new, create new behavior, testing array. So something I've never done before is try and create an array with a called action. Because normally in here, this array is tied explicitly to the integrated behavior controller that it's made from. So even if another unit is using the same code, their arrays will be different and they'll be attached to the behavior controller. They're not attached to the unit, they're attached to the behavior controller. So if you have a removable behavior controller, you can actually give that array to another unit by giving it that behavior controller. So my curiosity here is, if I have this behavior here that is making a call to another behavior that is in the library and is not explicitly stored on a behavior controller, can I save that array to this library instance? And then could I use that same array across a ton of different units? Because if I can, that's fucking crazy. So we're going to try it right now. Centralized array test. Okay, so here, what we're going to do is we're going to mem insert this bad boy right here. And if we insert this memory, we're going to do an index. We're going to hit silica, and the value we're going to give it is going to be a crystal. Cool. Save that bad boy. And then we go over here to testing array, and we call. And we're going to call the centralized array test. And when we play this, this subroutine will run and add to an array. And either it will add to its own array, or it will add to the array of the program that called it. So let's find out. We run it. Then we stop. This memory array has nothing. This memory array also probably has nothing. Because you know what I didn't do? I didn't hit. Okay, there's no settings here. This is interesting. There is settings here. So we're currently doing this when the memory restarts. We don't want that. So let's go ahead and set it up to not do that. And then hit play again. And then hit stop. Okay. So it's storing it in this memory array. Not in the memory array. Oh. What the fuck? Okay. So something weird just happened. Because this also had the same array. Okay. So arrays are shared. If you call another behavior from your primary behavior, it apparently has access to the array from the primary behavior. Which is kind of crazy. Wow. Because, so right now, we put the same, right? These are the same things, the same routine, same subroutine that we were using before. And we have no array. And we can play it, and we'll leave this one running for longer this time. And then we stop it, and now we have a totally different array with even more crystals. And when we go in here to edit this, we have access to that same array. And then if we go back to that other unit and we look at its array, it's only going to have, boom, just the 3. And this version of this is also just going to have, boom, just the 3. So this array persists through subroutines, which is awesome. I like that a lot. So the thing that we want to look at here is centralized array test. Okay, so it's not going to give us a centralized array, but what we can do is loop units within our visual range, which is 20. And we're going to filter for minables. And then we're going to get a unit out. And that unit is going to be current node multi. Cool. And then we're going to get its type. Because we want to know current multi type. I wonder if this is I wonder if it's better to get its type and then compare its type, or if it's better to just loop looking for all of one certain type of mineable and then loop again looking for the other type, right? Because I want metals and I want crystals. And there's no way really to just say only find metals and crystals. So I can do all minables, and then I can say get the type, compare the type. If it's metal, go forward. If it's crystal, go forward. Otherwise, go back. So we do 2 compares here. So we're going to compare register. And we're going to get the current type. And we're going to compare it to metal. If they're equal, we're going to move forward. If they're different, we're going to compare again. And then if it's crystal, we're also going to move forward. And if it's not, we'll go back to the loop. That's probably the best way to do that. And then let's see. Should we add all of them, or should we compare them again? Let's also get resource number. Let's only get resource number if we need to. So get resource number, which will be done in both of these instances. The resource we're going to get is the current node multi, and the result is going to be current amount multi. Perfect. And if that amount is greater than 10,000. Yeah, let's make it 5,000. No reason to be greedy. So if that value is greater than 5,000, then we will add it to the array. And the way we're going to add it to the array is we are going to take the current type as the index, and the value will be the current node, if equal or larger. The reason we want to insert this to the array based on So the reason we want to insert this into the array based on its type is that way we'll get an array that's got two lists in it. So your array is a list of lists, right? It's 2-axis. And so the ID is an image. In this case, it's going to be the type of the resource. And so those will go here. And then your index is here. Because I didn't give a number, right? Because I just gave the ID, which is the type of the resource, it will always append any new inserts onto the end. And so it'll just keep adding them. So we're going to get one list that is metal ore, and we're going to get one list that is crystal. That way, when we go to decide which metal ore we want to work off of, we don't also have to parse the crystal. We'll just parse the metal for its largest value within that circle, and then we'll compare all of the crystals to the metal that we choose. And so that will reduce the overall number of things we have to look through. I think. C'est possible. But that should be good enough. This doesn't need to be called centralized array test. This is creating resource array. Let's put multi in there. We're gonna try and start actually naming stuff in some way that makes sense to us. Because if I don't, I'm gonna get lost. Okay. So when we come in here, oh, wrong. Okay, so this has the right thing now. And so in between each of these, we're going to call this subroutine. And we're going to build out this array. So we're going to create there, move this back. And then we're just going to copy this because it's super simple. And then move that over and paste. And then move that over and paste. Well, dookie. Okay. Okay. Oh no. I got spaghettified. I've fallen into the black hole. Boop. Can we just lock these? Will that work? Okay. Then we can unlock this one. Then we can just move all these. Hopefully. Oh, nope. Wrong one. I don't know what I'm freaking doing. Boom. And then we go in here and we check that. Bring that one back. Unlock that one. Boom. Boom. Unlock that one. Boom. Boom. There's probably somebody out there who's smarter than me and could make this less garbage. I'm sure there's some math in here that I could do that would just automatically loop through. Right, because I'm creating basically a loop here, right? We're moving, we're calling this subroutine. We're moving, we're calling this subroutine. And so I'm sure there's some math in there that could set these offsets, and I could just loop it, and it would be a much smaller bit of code. But I'm not that smart, so... I think that's good enough. Let's make sure that things didn't get all wonky. No, we've got negative, or sorry, nothing, negative, 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 nothing, negative, positive. Nothing positive, 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 nothing positive, negative, positive, or positive, negative, and then nothing negative. Okay, I think that's right. So this gets me, once I find a silica, this gets me going in a big circle, picking up all of the resources and putting them in an array. Cool. Cool, cool. Cool, cool, cool. And now that we have our array, we want to parse that array. So let's see. This loops units, finds a silica, and stores it. So let's see if everything that I've tried to build here is actually going to work. And the way we're going to do that is we're going to go just manually walk over to a silica. Where's somewhere where we had most of the resources? There were too many bugs over here. I don't want to go over there. We just need somewhere that has 1,000 silica. I think there was probably something good up this way. Here's 1,000 silica. Okay, so let's come up this way. And what we're going to do... we'll probably go stand next to this one, because this one is, I think, at least 20 away from this blight here. And this blight would stop me from going inside of it. So we're going to have to write some code that's going to help us identify where, you know, things like blight and stuff might be, that might stop us from penetrating super early in the game. And get some like exception handling style stuff. But I think this should be good enough that we can just come up here. Let's see. Ooh, this might not be good enough. We might end up in the blight. What are you doing to me? Oh, it's because of that little thing. Okay, I think we might be like right out. So I think we might be okay. So let's just go over here and we're just going to play this. And it should, okay. So it looks like it found it and now we're moving. And now we're in the subroutine and we're building an array. Except it doesn't look like the array is building at all. Maybe it just hasn't found any of the resources. Is it stuck? Also, we don't need this memory insert. We don't need to build this array. I think I might be stuck. Nope. We cleared it, moved. Okay, so there were just a ton of resources for it to go through. Let's go see if we moved to the right spot. We did. And you can see, I think I did the math right, because at 14, this is right at the edge. The reason this was important was that I wanted to basically get double vision, right? So double the distance. So we can get all the way out here. Because this silica is close enough to exploit, even if I had to build my base, like over here somewhere. And now we're just looping. Okay. And now we're going to go to this spot over here. Again, we're right on top of this. And now we're looping through the resources again. And so far, we haven't found a single resource that meets our criteria of being either metal or crystal and having you know what? I don't think this is actually checking properly. Because we've definitely seen lots of crystal. And it never went over here to get number and then compare the number. So comparing the types might not actually work here. We might need a different comparator value. I think that's probably true. So let's go in here. We're going to stop this whole thing. We're going to get rid of this memory insert here because we don't need it. Because as soon as we find a silica that meets our requirement, we're just going to do the check. We don't want to store a bunch of silica values and then go back through and find the biggest one and all that other stuff. If it has 1,000 silica, that's enough. We can just work off of that. Now let's check here. Clear variables on restart. Yes. And then clear memory array. Never. Okay, so we save those. And now what we need to do is we need to go into this subroutine and we need to figure out what are we... You know what? It's probably a match. Yeah, we can probably not even get type. I bet. If we just put this filter on here. we could probably just feed the unit in there. So we can probably get rid of all three of these. And then boom, put this match in here. And then if failed, we go down to another match. Ooh, we do need the type though, because we're using the type to create the index. So we are still going to get the type. But we can get the type later, actually. That's fine. So now we're going to check to see if we're matching either of those. And we're going to use the current multi to see. Okay. And then we get the resource number. We put that down. And then if it's good enough that it has all the resources we want, then we get type. And we use that type to create the array. If larger or equal, and then the unit is the current, whoops. The unit is the current unit. The type comes out. And we put the type right there. Okay. That should hopefully do a better job. So let's move back over here. We're going to go right back up next to this. This thing's going to hurt us again. Can I attack that? Yeah, I can. Dope. Get out of here, you. What is this? A phase leaf. Okay. Now we play it. We figure it out and we move. At least the moving thing seems to be working. That's kind of nice. Let's go into this subroutine. Okay. So it is checking them. So this matching actually seems to be working now. And it keeps checking and nothing is over 5K. And so it's just moving on. And so far it hasn't built anything into the array. But at least it's actually getting to that point to check that. And then we'll just come out here and we'll just take a peek. And I just kind of want to watch it do its thing. So you can see we're doing a pretty big area here. And we are definitely going to repeat some values. Actually, we're going to repeat a lot of values. So I'm not entirely sure. Going to this central point here extends us out this way a little bit. But it's also a lot of repeating values. And it's not extending us out that much. So, and we're going to repeat all of this, like this little crystal patch here that has just tons and tons of crystal is going to get checked over and over and over again. So we might want, yeah, and all we're doing is just adding like a little oblong shape up here. So we need to do some additional work to eliminate, for example, there's no metal in this whole area. And so searching all of these individual pieces, I bet you there's not even 5,000 resources in this whole thing right here. So we're not, well, maybe there is. But we could check, okay, here's what we need to do. So when we're doing this subroutine, the subroutine needs to start by looping all resources in range. And then it needs to decide, is there at least 10K metal? And is there at least 10K crystal? The reason I want to check for 10K is if there's 10K, there's likely to be a 5K node. But if we only search for 5K, then we're going to end up searching through all those little nodes over there that don't equal 5K. So we'll search for 10K and then hope that that means we pick up any 5K nodes. We could also set these up for two different values. We could say we want at least 5K metal, but we're okay with like 1K crystal. That could maybe be acceptable. But who knows? So loop nearby resources. So looping nearby resources, whoops, should get us looping our visual range. Scans for nearby resources in power field or visibility range. Okay. And then we get the resource and its value. So this is very important because we are going to get the resource and the amount of it. And then we just want to run a couple of compares. We want to compare number. Or do we want to match? We probably want to do these matches. Nope, these are just for units. Could we get the type? It says of an item or unit. Probably won't work. Might just want to compare nums. Because we're getting each resource here. So we're looping nearby resources. We're getting all current resource. So we're getting all of one of the resources. And if we find enough, these are actually going to be, So if we find enough of both, we move on. So how do we know if we find enough of both? We're getting all the resources. We're getting the different values. We're getting how many there are. But we only have one resource at a time to work with. So we could just say if the value in here is greater than 10K, regardless of what type of resource it is, then we change a variable, maybe. If we have at least 10K, we could also put it in the array, but I don't like that. Oh, we've found. That's cool. I didn't realize that this was still running. But apparently we found a couple of bits here. That's interesting. I don't think we can get the type because these aren't units. We could separate. I don't think the word they use is separate. Also, it doesn't seem like what I'm looking for is actually in here. There we go. Separate register. Weird. So instead of comparing right away, we could separate this register into its number and ID value. I think the ID value is the one that I would be using. And then we can compare the ID value to, right, we could use this same match. So we put that in there, put that there. And then we duplicate this match logic. Put it right here. And then if it matches either of these, then it moves forward. And if it doesn't, it goes back. And that would be the ID, which is all resource ID. And these go right here. And then the number is all resource value. These probably should say all node, not all resource. But that's fine. Okay, and then we compare those numbers. So this lets us look at the different IDs. If it has at least crystal or metal at 10K, we would move forward. But I don't actually want to do that because this is a loop. So this technically only wants to run when this is done. And it only wants to run under the circumstances that I've found both crystal and metal. And why did that just vanish? Wowza. Thank you, video game. Okay, well, let's get out of that real quick. Let's get out of this. Let's just take a look at what's going on here. What is homeboy doing? Oh, did he find a new silica node to search? I think he did. Yeah, he's looking at one of the other silica nodes now. That's actually kind of hilarious and a little bit awesome. Okay, that logic is running really well. I'm actually pretty impressed, even though it's a little sloppy to not have it in like a loop or something. Um, it seems to be running pretty good, so I'm okay with it. Hmm. Oh, this is hurting my noggin. My noggin hurts. Okay, so I just lost all of what I had just been working on in my little subroutine here. So I need to do the whole comparison thing again, which means we need to separate. We're separating this register into all resource node mount. I guess there's only one M in amount. And then all resource node ID. Okay. And then we're going to match again. And we're going to use the IDs to do the match. And then let's go ahead and just move all this stuff up. And then all this stuff comes down here. Nope. Okay. Well, so if we get a match on either of these, we go to compare number. And we're comparing against 10,000. And we're comparing the all resource number here. And then we need to do something with this information that says one of these resources has enough. So do we maybe need to copy it to a value and then check to make sure that both of those values are not null? Like, could we create, if we do copy here, and we do if equal or larger, we copy we can even copy the all resource value into, no. And then I was just going to check if it was null or not. But that's not. What do we want to do here? How do we want to decide? Because we could just save both of these values. No, we need to add to a value. Let's see. add to... Can I make a new value here? Doesn't look like I can make a new value here. How is that possible? I wonder if I could make a result and then put it on there. If it's null, then it would still add to it, right? That seems reasonable. Let's see if that would even work. So... resources meeting criteria. So we're just keeping track of how many resources meet our criteria. And then we're going to go ahead and add a 1 to this. And then when this is all done, what we'll want to do is we'll want to compare a number . Nope. Okay, game. Kiss my ass. If equal or larger, we'll compare this value to 2. So if at least 2 resources are higher or meet the criteria, then we move on. And we do the whole loopy-loopy thing. And that should be it. And this way, we only run a quick loop. Because this loop that does nearby resources just gets the value of all of the resources of a single type and then gives you the value. So if there's a whole bunch of a resource within my visual range, then, well, if there's a whole bunch of at least metal and crystal within my visual range, then we do it. Actually, it would only do only, because right now I've got these filtered. But yeah, so if we have metal and crystal in greater than 10K amounts, then we actually look to see what we've got. And so that should actually make this whole thing move much faster. Our array is currently populated. We're going to clear it because we want to look. And then we're going to go ahead and play this. We're going to go right in here. So we're moving. We hit our spot. We go into our subroutine. And we didn't find any of the resource. We didn't find any of the resource. We didn't find enough of anything. We're not ever moving forward. So we're not matching these at any point. So the ID isn't working. Because we're never comparing to the value. And I know for a fact that we're hitting at least crystal. So this ID system, separating this register, didn't work. Because it's trying to compare that ID, and it's not working. So let's put this here, save it, and let's see. Nope. Every one of these should at least hit on crystal, and they're not right now. Okay. What if, let's just take this separate register out for a second and see if this will just take all current resources as a unit. And then let's save that. I don't think so. Yeah, it doesn't look like it is. Okay. So we need to find a way to figure out what type of resource we're using here. It looks like this stop is also for the parent node or the parent behavior as well. That's interesting. Okay. The only other thing that I can think to do here is just compare register. Hey, it's going all right. We're doing okay. Things are a little complicated. I'm having trouble comparing this thing. So we're going to compare the current to... no, this is only equal, not equal or greater. Fuck knuckles. Could I maybe compare item? If we compare item, will this work? Maybe you want to work? Save it. Go forward. We're gonna get to his spot. Where are you going? Oh, I feel like we actually moved on to compare number here. Yeah, we did. Okay, that's the one right there. Compare item. So it's checking it. It's finding that it's not getting both of them. Okay. I think we're good there. I just don't think we have anywhere right around here where there's both metal and crystal. So it's not going into its loop to see, to build the array or whatever. So if it doesn't have both resources within its range, then it just doesn't care. But it seems like it's working. That feels pretty good. So there are some more things that need to get added to this. For example, right now, we're not looking for silica. So we still need to create our logic that actually does our scouting and goes and finds silica specifically. But once we find a silica, we have created sort of an opportunity for our command center to search around that silica specifically for the other resources that we might need. And so this is going to make sure that we find a spot that has the 3 big early resources. Now we just have to do some scouting that will find the different silica nodes for us. And then we have to do the triangulation that takes the largest metal node within range of that silica node, and then compares it to the distance of all the crystal nodes, and then gives us a little triangulation so that we can drop our base. The triangulation that I want to do is going to be a little different than just the center of the 3 items. What I'm going to want is I'm going to want the closest location to the silica that has the metal and crystal node still inside of the logistics network, so that we can be working inside of our logistics network early. And then we can expand out to the silica node. But we're going to have the crystal and the metal nodes like in the network from the jump. So we'll find a spot that's in between the crystal and metal and has both of them in the logistics that is as close as possible to the silica. That'll be a bunch of math. That'll be pretty difficult for me. But we'll figure it out. But I feel pretty good about how far we've gotten so far. I think this is a 2 square, which I think is why it was here. Yeah, I don't even know. Anyway, we're just going to leave it right where it was at. But this is going to be a much more effective, starter logic than what I had previously. It was just random movement, guess and check. Oh, look, there's enough of the resources I want. Plunk it down. This might not be the best version. There is an argument to be said for just getting a shitload of crystal and a shitload of metal. And then just, whatever silica you can scrape, call it good enough. And then build from there, because you'll be able to get started that much faster. So, and this is why I wanted to start the contest, right? This is why that's so important, is there's lots of different ways to skin this cat. You can, you could literally just, wherever it sets you, just plunk your fucking base down, because it almost always sets you within range of crystal and metal. And there's actually, this one right here gave me tons of crystal and metal. It's a little bit outside of my range, right? So I can't really have all of these things inside my logistics network right now. But there's so much that expanding out to incorporate all of this would actually be fairly easy. And so any sort of movement that I go do is probably worthless, right? All that scouting and stuff like that isn't going to find me a base location that is significantly better than this one, and it's just going to waste a bunch of time. So that's probably another check that my logic needs to do, is it needs to just look first thing, right? Look around you. Do you have a stupid amount of resources? If yes, build. Just straight up. And so even though, there's no really close silica, I'd have to get built all the way out here, I think, to find my nearest silica. Or maybe I could build out this way, although there's a bunch of bug shit over here. But there's a couple thousand silica over here. So there's lots of silica near me. It's just not within my little radius. But this is actually a really good spot as far as that's concerned. And actually, if I'm looking around, I was complaining that there weren't any plateaus earlier, but this whole area is actually kind of plateaus. There's just plateaus all over it. So it might be a fairly defensible spot. And that's another thing that we're going to be looking at, is we're going to need to find a way to identify all of the choke points coming into our base. Because owning these chokes, right, owning these plateaus is going to do wonders for being able to keep people from coming in. Either owning the plateaus themselves. I don't know. So the thing we'll have to check, or the thing we'll have to know, is whether or not having structures up on a plateau increases their range at all. If it doesn't, it'd be cool if it did. But if it doesn't, then that means we don't actually take over the plateaus. We take over the space on the inside. One thing I noticed is pathing is weird as fuck. I've seen bugs go over what looks like a 90-degree face. Yeah, that definitely has happened. 100%. I've seen myself do it too. It's because this spot right here, this square right here, is probably passable, but it's probably large enough that it looks kind of like it's in this spot right here too. And so in order for the game to not get your units just totally stuck, when they're trying to go down immediately next to a place where they're supposed to be able to go down, it probably just lets them. There's like a little bit of a grace in there. So the units aren't getting stuck on what is obviously like right next to passable terrain. There's a lot of things that devs do to make... Oh, you've seen it where there's no ramp anywhere? Oh, that's crazy. I mean, it's possible that maybe the plateaus are just passable. That maybe you don't have to go around. And maybe I've just been using the ramps because I think that I'm supposed to, but you don't actually have to. I don't really know. There might be no choke points in this game. I have no idea. But we will want to identify choke points. Because if we could, build, it really is hard to tell. Yeah, we'll get some testing done. But if there are choke points and you can control those choke points, then you can put really good defenses. So the value of a choke point is not that you want to build in the choke point, right? You don't build right here because this is the kill box. You want to build in a place where all of your units, because there's an arc, right? This location right here, there is an arc out here where every single unit on this arc is at maximum range to this location. And it's probably not quite that steep of an arc. It's probably more like this. But every single one of these units on this arc can hit this point right here. And the reason that's important is because when you have a choke point, your enemy is forced to come through that location. So they drastically limit the number of their units that can attack your static defenses, and all of your static defenses only have to attack one unit at a time. This is why, like, the 300 was hella stupid, because the 300 fought inside the pass. Like they walked through the pass and then fought on the other side of it, which was crazy. If you had a pass like that, then what you would have wanted to do was fight on this side of it. And then maybe have some people like up here who were like pushing rocks down into the pass to smother all of their stuff. But they went and fought like over here. And admittedly, where they were at, you know, they had the ocean or whatever, so they had that narrow area that they were fighting in. But they put themselves inside of a narrow area as well. I don't know. It was all really weird. But that was definitely not the best way to fight in that spot. If you'd have just backed it up and fought from here and then just buried them in rocks, you would have had a much easier fight. But we definitely want to look into being able to identify those choke points and defend them. Because that's going to be a big deal for PvP. I'm happy with the code that we wrote so far today. I think that was some stuff that we really needed to get out of the way, right? A better way to identify our base spot. 100%. I'm also really excited about the new information that I know about arrays now. It's really cool that you can call subroutines, and those subroutines can build arrays that all other subroutines that you run will still have access to. So, I mean, you could build arrays and do stuff. My mapping unit and all of its code is going to get so much better now. Because I'm going to be able to call subroutines for tons of stuff. And it's really going to clean up that code. Because that mapper is probably going to be my most complex code. Because it's got to know everything about the whole map. And it's got to constantly be taking in info. It's going to constantly be spitting out info. It's going to be pretty crazy. So it's super cool that we'll be able to build. This is like, oh no, that's just a stack size. Never mind. But we'll get to do some cool stuff with that mapper now. Which is going to be hella fun. Things are definitely starting to be faster. I mean, we wrote a pretty significant amount of code today compared to what I normally get accomplished. As I've started to understand, especially as I've started to understand variables and arrays better, specifically how variables hold lots of strange types of information sort of all at the same time has really made it a lot easier for me to get this stuff built. And I'm starting to understand some of the logic behind, you know, what some of these nodes and stuff are. Because these nodes are effectively behavior calls, right? You're calling a subroutine to compare the items. It's just a black box subroutine that you don't have the ability to change, right? You're calling a method in an API. And so understanding what's kind of under the hood here is really helping make things a little faster. But yeah, I mean, that wasn't a super long one, only 3 hours. But I think I'm going to go ahead and call the stream there today. I think we've made significant progress on this little bit of program here. Couple of things that I want to consider in the future are a good scout pattern for all of these to go through to find silica nodes to search. So something we'll want to do is we'll want to go find a bunch of silica nodes with at least 1,000, and then we'll want to go run this search parameter that we just built today on each of those silica nodes. Or at least, maybe not on each of the silica nodes, but on one of the silica nodes within a certain area. So we might also need to check like the distance to all other silica nodes in our little array. And then if there's another node within like 5, we won't check it because that wouldn't really be any reason. But yeah, we'll look into some of that stuff. I'll do some research and then we'll get back at it tomorrow. So yeah, thanks everybody for coming and hanging out. Thanks for the little bit of help. I appreciate it. And yeah, I hope that everybody has a great rest of their day. And I'll see you all on the next one.